Hello everyone, and welcome back to another devlog for QUACK-OUT. So first off, thank you guys for the continued support of my game, and also this channel. I'm almost at 700 subs, so thank you guys for that. And thank you to those who've actually played my game, link in the description, and given me feedback with through my Discord channel. So I appreciate all of that, and I'm really looking forward to this update that I'm about to release. So if it's not launched by the time this video is uploaded, then be checking for it because it will be up soon. But otherwise, you might be able to play this current version of the game. So big things have been happening for this new update. So first off, I have bots, and for something like this, where I know that I feasibly do not have a large enough player base to sustain the required interaction for a video game like this, where it's an arena FPS. So I really needed to get bots implemented in the game at some point soon, just to make sure that people would still be able to have fun, and that anybody that's new, especially, I know I have you as my hardcore fan base watching this video, but anyone who's just browsing and clicks on it, they're probably not going to have a fun time as of right now, or as of but before this next update. But if they have bots to play with, that will increase their enjoyment substantially. So I'll go ahead and actually show you guys a demo of those bots right here. And let me turn that volume down a little bit. I also have a couple of new settings. I have the ability to disable shadows if you're still getting bad performance, and then I also have an FPS counter that you can show. I also at some point will upgrade this to also show ping, but right now it's just FPS. So I'm gonna go ahead and create a new game, and as the host you're able to enable or disable bots. So we'll just go to Classic Temple over here and go ahead and start this. Still have, choosing your team as usual. And so I made it so that so the bots spawn in right here. So you can see they're all here. They all have some nice puns for their names. And basically the way that they work is that they have a bunch of navigation points that they're able to reference, and you see they're pretty aggressive too. They have a bunch of navigational points that they can reference, and that will give them a patrol location. And they also have a basically the way they work is they have a navigational objective, which could be a patrol point or a player or some other random position, but they also have a secondary objective, which is based on just a couple of different factors. So if they're low on health, you'll see that they actually will tend to go into the egg mode to shield themselves. And then if they see a player, they will try to look at the player and attack the player as their secondary objective. Otherwise, they might be looking at just random points on the map as their secondary objective. So yeah, this is pretty cool. You can actually just host a dedicated server and just watch them kind of, move around and everything. And they also have another layer that was just needed because they basically use a bunch of raycasts to determine what's in their line of sight. So they can, basically do some basic obstacle navigation. So they'll basically, if they look at a wall and they want to get around the wall, they'll try to follow the normal of the wall to still get to their destination. And also I have these hidden areas, like in these indoor parts specifically, where the bots have a hard time navigating. They'll be recommended like a special patrol point to go to, and they will pretty much always follow that. And then, let's see, I know they're just going at it here. I guess another key thing is that obviously my game is very vertical, so I couldn't really rely on a nav mesh to actually handle navigation for me. I might could for any sort of ground navigation, but it just didn't make sense for this, and I was worried about my game also potentially having too much mesh info, and could increase the amount of resources that are needed per level to make each level. So I didn't want that. I wanted the bots to be somewhat independent. They can detect when they're about to fall into lava, and they'll jump. They can detect when their current navigational objective is significantly far enough below them, and then they'll start gliding to their objective to try to increase their speed. And so yeah, there's a lot of cool things. They'll kick players if they're close by, as you just saw twice. Man, he just murdered 2 people. But yeah, so I'll actually show you one of the key things that I did to increase the randomness of that. So here's my bot input, which is basically, this is all my bot AI. So to give you an idea, guys, I think I mentioned this in a previous video, but I have an input script that I use underneath my player. And the input script, the basic one is, handles your keyboard or mouse or controller or touch input. And this one will have like, your touch controls and everything right there. And also it will read from your mouse and keyboard and all that. But I also have, I specifically designed it so that I would be able to swap it out with a bot input. And so for my bot input, it's able to actually emit all the exact same actions that my other input script does. And so it's basically able to be plug and play. And so if I eventually developed another bot input script, say if there's like an option to have a higher quality bot or something, or a different difficulty of a bot, I might actually have a different script, to handle that. So that's something that, you might be able to consider for your project, if you actually have to completely have a bot that only is able to execute the actions that any player is able to execute. So just keep that in mind. Alrighty, that covers the bot AI. I am now going to tell you how I was able to optimize the heck out of my game. So just to give you an idea, on the live client of QUACK-OUT for gotm.io, the website which runs Godot with WebGL. If you run WebGL with my current game, and I have only Chrome running, and I put it, maximize full screen, I get about 90 FPS, and that's before I add, or I get about 110 FPS, and that's before I add bots. When I added bots, I suddenly saw that my game was dropping to like the 70s or 80s for FPS on just the basic levels that you didn't think would cause drops. So I was curious as to why that was happening. I was like, is my game not able to support like more than 1 or 2 players? It didn't make any sense to me. And so I had to really dig through, and I found out that WebGL does not like transparency at all. So if you're making a 3D WebGL game of any sort, or one that's on mobile, don't use transparency. Try to dither. So you probably saw this in the beginning of the video. This is not a YouTube compression artifact. It might still look weird on YouTube, but hopefully it doesn't look too weird. But this is actually not an alpha texture right here. This is actually using dithering to achieve an effect that makes it look like it's transparent. And the effect is pretty convincing, especially for my game's graphic style, which is kind of retro in theming. But the player shadows used to be, let's see, where's my player shadow? Yeah, here it is. So my player shadow, where is it? I can't see anything. Okay, there we go. So my player shadow is, you can actually probably see this pretty well. Yeah, so my player shadow was the initial thing that clued me into that WebGL does not like transparency at all. And as soon as I changed the shadow to use a dithering shader, and I'll just pop up the shader code really quick, so in case you're wondering how it works, it's right here. It does this weird thingy right here. You can screenshot that and try to replicate that. Basically when I swapped out the shader for the shadow, then when I had all my bots on screen with me, then I saw that I was able to get like a huge like 30 FPS boost, and I was like, okay, well, what else is using transparency when it needs to be using dithering? And so I swapped out every single thing I could that was using transparency and swapped it out with a dithering shader, and that massively jumped up my performance. And I guess I'll give you guys a brief explanation as to why that is. So if an object is using transparency for alpha, basically what's going to happen is that it's going to have to draw the objects surrounding that transparency potentially like several times in a row, especially when there's multiple planes of transparency on top of each other. So if you have like a cloud of particles that all have transparency, you are going to be wasting a lot of resources, especially in WebGL where it's not very optimized, even if you have a monster graphics card and everything. So and especially like people on mobile said like the game is unplayable, and I tended to agree with them. It's like, yeah, I don't think my game is playable on mobile right now. And I was only able to get about 20 FPS on my high-end phone. So after I did this change, I got it up to about 35 to 40 FPS single-handedly. And that's not all that I needed to do to optimize the heck out of my game. So basically, another thing I did was there's a nifty thing in Godot that you can do. And basically, let me try to find that. Yeah, so basically there's this way that you can, it's on the player script, that's why. Yeah, so I have the ability to make it do a slow process update. So basically, on my player script right here, I have it so that when something is off screen entirely, and it's a bot in this case, or another player, it will actually slow it down to a 20 FPS update rate for both process and physics process, because basically you can do this call right here, which is set physics process true or set physics process false. And so, and you can also do the same for set process. And so that's what I did. And then I would start another timer that's on this node that would actually call those functions on timeout. And so that saved me a lot of performance as well. If something's off screen, you don't really care about it. If you're a client, it does potentially have an issue with bots not being as accurate, but I thought that this would be an important enough optimization to justify it. So yeah, that gives you an idea of what you can do. If you have bot AI of any sort, you can actually make it update at a slower rate than 60 FPS in this case, because my physics process is at 60 FPS. And then that will help you free up a lot of resources. And then the last thing, this thing I did not look up or anything, but if you are dealing with a game with a lot of physics going on, do not use Bullet for web development. I don't know why that is. Bullet is more performant in, I think, Windows, but for Godot Physics, it's way more performant on WebGL. It's probably designed better to be on a single thread, whereas Bullet Physics is designed to be multi-threaded and everything. But whatever the Godot team did with Godot Physics, it works a lot better. It's a little bit more buggy than Bullet Physics, but I think the performance gains are huge. It single-handedly brought my game from about 110 FPS to a locked, my monitor's refresh rate is 165, so 165 FPS. And yeah, so that was a huge optimization, and on mobile, that really was transformative. It brought up my phone to about 40, 45 FPS. So that gives you an idea. I mean, I had to use the profiler, which if you don't know what to do, it's basically this guy right here, where you can start it, and it'll actually show you the frame time, what functions are taking up the most time I'll actually show that off really quick. So you can actually see when a function is taking more time than you think it should. Yeah, I'll bring that up. And so if we do this, I also better optimize this map as well. I found a few issues with it, mostly related to transparency, believe it or not. So yeah, here we go. And so you can actually see that my script functions are taking up under a millisecond. And if I look at the bots with my field of view, then it should, in theory, take up a little bit more time because they're now updating at a full 60 FPS. But yeah, so it kind of averages out around. It's not really getting above a half millisecond. So that gives you an idea of how optimized GD script code is if you know what you're doing. So that's full like raycasts, everything, and it's handling it like a champ. So also you can check the physics time, which this one is the clue, what gave me the clue in onto what I need to do with migrating to Godot Physics versus bullet physics. And under bullet physics, it was about like 5 to 6 milliseconds, and then in Godot Physics, it's sitting at about I believe about 3 milliseconds. So it's about a 60% increase in speed over the bullet physics, for at least for WebGL. So anyway, I'm really excited to share this update with you guys. This is going to be the update, quote unquote, that will fix a lot of the issues that you guys had brought up. I really hope you guys are able to jump in and enjoy it. And I'll be working on new maps and modes next, once I think that this mode is stable, or this current update is stable enough as is. And I'm still, in theory, going to be on track for a beta release in sometime in May. I might have to push it back, just depending on how my schedule works out. I am doing this just in my free time as a hobby, so it'd be one thing if it was my full-time position, but yeah, it's just a hobby, so please understand that. And I know you guys probably do. You probably are all hobbyists as well. Maybe 1 or 2 full-time people, but yeah, so I'm really excited, and I hope to see you guys in QUACK-OUT.